So this is what you should see on slide 55 if you got there and hit the present button. All right, so the law of conservation of matter, also called the law of conservation of mass, is when you, is a science law that says that no matter can be created or destroyed, it changes form. So that means like water, you know, when you boil water, it evaporates, but it's not really gone, it just changed into a gas. So that kind of thing. Elements in the reactants and the products are equal. And the scientist who first demonstrated this was Antoine Lavoisier. So we have reactants and we have products. This side of the arrow are called the reactants. So those two compounds would be reactants. And this compound would be the product. So what we look for is, do we have the same number of atoms of each element on this side as we have on this side? So because according to the law of conservation of mass, both sides have to be equal. So for example, Mg, we've got 1 Mg over here, so we put that there. We've got 1 Mg over here, so we put that there. Oh look, Mg is equal on both sides. Then you go on to another element, O. So for O's, we count all the O's on this side. I've got 1 O there and 1 O there. That would be 2. On this side, I've got 1 O there, but if you remember, if there's a number out here, you multiply it by how many there are inside. So I've got 1 O times 2 is going to be 2 O's. So I've got 2 there. Oh, look, O is balanced as well. Then we go to H, hydrogen. There's 2 hydrogens on this side, and there's 2 hydrogens on this side. 2 times the 1 is 2. So this would be a balanced equation. My reactants are equal to my products. So this is an equation that you do not need to do anything to. It is fine just like it is. If we go to the next slide, and we reveal everything on that slide. So what's going to happen, of course, because we can't make it that easy for you, we're going to deal with equations that are not balanced, and you're going to have to balance them. So under the equation, you're going to list any elements and how many atoms there are present of each, which you saw in the last one. Then we're going to use coefficients as multipliers to balance the equation. You cannot change the subscripts because that would change the substance. So, for example, if I have this equation, these are my reactants, these are my products, and I count. I've got 1 Na over here, I've got 1 Na over here, so Na, 1, 1. My next element, chlorine, I've got 2 over here, but if I look over here, I only have 1. Now, that presents a problem because my chlorines are not balanced. So I'm going to show you that same equation up here on the board. So I've got, so this is what I have, same as what you just saw. So where I have the black marks are the only places where I can put a coefficient. So I could put a coefficient there if I need to. I can put a coefficient there or there. I cannot change a subscript because that will change the element. For example, if I wanted to put like a little 2 there by the Cl or after the Cl, so I would have NaCl2, that's no longer going to be, regular salt. It would theoretically change to something different if that really worked out. So you cannot change the subscript. But I can change the coefficient and I can just have like more Cl2s, like instead of having 1 Cl2 where I'd have 2 Cls linked together, I could have 2 Cl2s and I could have 2 molecules of 2 Cls linked together. So what we do then is we look to see where our deficit is. So our deficit here is on Cls on this side. So the only spot on this side where I can put a number is there. So I'm going to put a 2 there because 2 times the 1 Cl, again, using the distributive property, 2 times the 1 Cl gives me 2. So now I no longer have 1, I now have a total of 2 on this side. But when I did that, that now gives me 2 times the 1 Na. Uh-oh, now I just messed up my Nas. Now I have 2 Nas. So now I have a problem again. My chlorines are good, but my sodiums are not. So if I go over to this side, the only place where I have sodium is right here. And I've got 1 sodium, so I'm going to put a 2 there. 2 times the 1 sodium is 2. And then if you look at my equation, it is now balanced. I've got two NAs over there. I've got two NAs over there. I've got two CLs over there, two CLs over there. And that is my finished equation. It's okay that we didn't put anything in that blank. There's kind of like in math, there would be a 1 there, but we don't need to write the 1. So then your finished final equation would be what you see on the screen there. So we have 2 NAs plus Cl2 is going to yield 2 NaCl. If I were to draw this out, this would be like 1 Na, 2 Na, and they're not attached to each other. So that's what 2 Na would look like. Cl2 would be, if I have 2 Cl's linked together, and I just have one of those molecules, and then 2 NaCl would be, I've got an NaCl, and so here's what 2 NaCl's would be. I've got one molecule of NaCl, and then I've got a second molecule of NaCl. And so that would be the finished product for that, or the finished balanced equation.